Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number, and I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2. And then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1. So I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1. So I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these two, and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed, or sorry, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number, times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other, and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. this is going to equal 4 is equal to 1 plus 3 to the power of y minus 1, and this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out, and I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4, and y is equal to 2. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 30. So I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 30. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of n and m. So in this case, I have 2 to the power of 3 to the power of x, and I'm going to switch the places of 3 and x. So I get 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 30. Now, I'm going to let the variable u equal 2 to the power of x. So now if I substitute in u for 2 to the power of x, I get u to the power of 3 plus u is equal to 30. And now I can subtract 30 on both sides. So then these two cancel out, and I get u to the power of 3 plus u minus 30 is equal to 0. Now we have an equation here, and we need to find what value of u makes this equation equal to 0. So what I'm going to do to start is rewrite 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. Notice how we have something in the form u to the power of 3 plus u. We could think of u as 3 in this case. So 27 is the same thing as 3 to the power of 3, and we have this minus 3. Now I'm going to put this in the form u to the power of 3 minus 3 to the power of 3 plus u minus 3 is equal to 0. So now, if I put this in parentheses real quick, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this turns into u minus 3 times u squared plus 3u plus 9 plus u minus 3, which is equal to 0. And now, because both of these terms have a common factor of u minus 3, if I factor out u minus 3, I get u minus 3 times u squared plus 3u plus 9 plus 1 is equal to 0. And now from here, 9 plus 1 is 10, so I get u minus 3 times u squared plus 3u plus 10 is equal to 0. Now this gives me two equations. I get u minus 3 is equal to 0, and I get u squared plus 3u plus 10 is equal to 0. So u minus 3 equals 0. That's pretty easy to solve. All I have to do is add 3 on both sides, and I get u is equal to 3. Now remember how we let u equal to 2 to the power of x, meaning 2 to the power of x is equal to 3. And now to solve this, I'm going to start by taking the log on both sides, so I get log 2 to the power of x is equal to log 3. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I have log 2 to the power of x, and I can move x to the front. So I get x times log 2 is equal to log 3. And now if I divide both sides by log 2, these two cancel out, and I get x is equal to log 3 over log 2. Now, log 3 is equal to 0.4771, and log 2 is equal to 0.301, meaning this is equal to x is equal to 1.539. Now, going back over here, we have u squared plus 3u plus 10 equals 0. And let's use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get u is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And this gets me negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 10, which is 40, all over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. Now, the square root of negative 31, that's a negative number, so that doesn't work, meaning my only solution is 1.539.